Math 3, Unit 8, Section 5. Today we're talking about the modified box and whisker plots along with percentiles. So the modified box and whisker plots contain something called outliers. And we are going to talk about that today. So last time we learned the 5-number summary. Okay, do you guys remember that? And how we find the 5-number summary? And so on a graph with your 5-number summary, this end right here is normally your minimum value. Then you have a point here with your quartile 1. You have your median here in the middle. This is the value right here for your Q3. And then normally this value right here is your maximum value. So this would be called a box and whisker plot. The modified box and whisker plot will end up having the outliers, which we're going to talk about. So notice here these 5 points. That's your 5-number summary values. Okay? And then you make a box because most of your data is within this quartile right here within Q1 to Q3. Okay? So right here just talks about how you make the box, what I just said with Q1 and Q3. Your whiskers are just the lines that go from Q1 to your minimum and Q3 to your maximum. You always want to make sure that you label your axis. And so that's where you kind of have to decide, okay, each of these values needs to be 1, or maybe they need to be 5 or 3. So where you're making your marks, you always want to label how much each of these little marks stands for. Okay, so now getting on to an outlier. So an outlier is a value that doesn't follow the pattern of the other data values. Outliers could have a drastic effect on the mean and standard deviation. Okay, to determine whether or not an outlier exists, upper and lower boundaries are calculated. These boundaries are not necessarily elements within the data set. They are values to help determine if outliers exist. Okay? How you find this is by first taking your interquartile range. Okay? And so how you find your interquartile range, or IQR, is you just subtract Q3 and Q1. So whatever value you get for Q3 minus Q1, that gives you your IQR, or your interquartile range. Once you have that value, you multiply it by 1.5. This is how I remember it. So when you have that value, multiply it by 1.5, you get a value. You take Q1 and you subtract this value, and that gives you your lower boundary. And oftentimes I'll abbreviate with this with LB. Okay? For your upper boundary, to see if there's any outliers on the top half of the data, is you add that value to the Q3 value. So upper value is where you're adding, and lower boundary is when you subtract. Okay? Outliers are any numbers in the data set that are less than the lower boundary or greater than the upper boundary. Okay? If you have an outlier, we normally just put like an X for that value, but it's not then included in the whiskers. The whiskers are then drawn from the highest and lowest values that are not outliers. And of course, we're going to practice this so it makes more sense here in just a minute, but that's the gist of it. Okay, so moving on to the next page. So we have this set of data, and they are not in order. So the first thing we have to do is write our data set in order. When I have it written like this, I like to just remake my numbers underneath here, just because it kind of keeps it organized, and then I can make sure I have all my values. So starting with my lowest values, what would my lowest value be?
1.
Good. Okay, and so then I'm going to go through and I'm going to pick all the numbers that start with a 1 And this will help me. This is how I organize mine and try not to miss anything. So see all those started with a 1. Okay, so now looking at those numbers, my smallest value there is now 10. And then next is going to be 12. And then I have 3 15s. And we have 2 16s, 1 17, 1 18, and 1 19. And then I go to all the numbers that start with the 2. And so starting I have a 20 and a 21 and a 25. And then my last value is 42. Who remembers what's the next thing we're supposed to do on this? So we first have to find our 5-number summary. So in order to find the 5-number summary, you want to know how many pieces of data do I have. And so I'm going to go ahead and number my data set. So okay, so we have 15 pieces of data. So we need to find our low, high, Q1, Q3, and our median, right? Or min and max. So this right here, pretty obvious. That would be my low value. And this value would be my high value. Good. Or min and max, however you want to do it. Next, for my median, how do I find my median? Yeah, 15. So I'm just going to put here, median is 15 divided by 2, which is 7.5. So since that's 7.5, that means my median is actually at which value? The 8th number. So the 8th number in my value or in my data set is right here. And so I'm just going to label that there as median. Now we have to find Q1. Do you guys remember how to find Q1? Yep, so this first part, and we do not include the median. So that first part, what is the middle value there? Or how would I find it for my Q1? So for Q1, I have how many pieces of data? Actually just 7, right? Because we don't use our median. And actually it's for Q, yes? No. So if you divide it by 2 and there's 2 in the middle here, then you would take the average of the 2. Okay, did you ask me if there were 2 middle values, would I then take it? Do you mean like if we used 8 and 9, would we use it? Yeah. Yes, then you would. It's just whatever your median value is, you don't use that as part of your data set. But in this case, because it is a value, this is my median, and so it can't be part of Q1 or Q3.
But if there's like 16 and 17, don't use it.
Okay, so there are 7 values. So we're going to go 7 divided by 2, which is 3.5, which means that my 4th number is my Q1. And so that means that from number 8, we're going to go 4 to the right. 1, 2, 3, 4. So 20 there is my Q3. Does anybody have questions on any of that? Okay, so now we have to check to see if there's any outliers. Do you have a question? Okay. Are you guys ready for outliers? Okay, so I'm going to label this so we know what we're doing. So for outliers, the first thing what we do is we take Q3 minus Q1. In this case, what are those values? So 20 minus 15. Do we agree with that? And that equals 5. Once you have that value, we're going to multiply that by 1.5. Okay? So 5 times 1.5, and you could do that in your calculator, and you end up getting 7.5. Okay? So in order to find if you're outliers, for my lower boundary, I take my smallest value. Nope, sorry, I don't take my smallest value. I take my Q1 value, which is
15.
And we subtract 7.5. And 15 minus 7.5 is 7.5. Okay, for my upper boundary, we take our Q3 value, which is 20, and we add 7.5 to it. And we get 27.5. Okay. That is a 7. Now, how you check to see if there are outliers is if there are any values that are less than 7.5, that is an outlier. So looking at our data set, do we have a lower boundary outlier?
Yes.
Yes. What are our outliers for that? 1. So I'm just going to put here, outliers, my values are 1. And are there any values greater than 27.5? Yes. And so 42 is also an outlier. So these values tell us, like, if there's anything smaller than this value, it's an outlier. If there's anything bigger than this value, there's an outlier. Okay, so now we're going to go ahead and make our box and whisker plot. The first thing we have to decide is we have a range of numbers from 1 to 42. And so we have to figure out what do we want to count by on here in order to make sure that all of our values fit onto the graph. And so if we count here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and so we need to decide what should we count by in order to fit everything on there. So we could do 4s or we could do 5s in order to get everything on here. If I do 4s, it's going to be off here just a little bit because this goes up to 42. Does that make sense? And there's 10 marks here. If we do 5, we can get everything on there. So either one would be fine. It doesn't really matter. It's up to you. I'm going to go ahead and just do them by 5s. Okay? So this starts with 0, and this is what we're talking about by labeling your x-axis. If you want to go by 4s, that is totally fine. Okay, and then it's up to you on how you want to mark things. We always have to mark everything. Okay, and so I'm just going to go ahead and mark the outliers to start with. So there's an outlier at 1. Now on this, the going up and down part doesn't really matter. It's like the y-axis lines. But I'm just going to go up by like 3 just to kind of mark things. So 1, there would be like an X here. And again, like I said, I didn't put it up here for any specific reason. I'm just going to put everything on that third line up. Yes. The only thing is that you want to go up at least by 1 or 2 because you're going to end up making that box. So that would be the only thing. Okay. And then 42 is about right there. So I'm going to mark an X there for my 42 value. Okay, and now we have to mark. So because 1 is an outlier, my low value is going to change on my box and whiskers to the 10. Okay, so I'm going to have to make a point here at 10. And then there's another point at 15. The median is at 16. So we're going to have a point there for our median. 20 is my Q3. And then because 42 is an outlier, we have to also mark 25. So your box goes around your 3 middle numbers. So your box is from Q1 to Q3. You have a median here through the, or like a line through your median. And then your whiskers go to the end points that are not outliers. Now, if this number had not been an outlier, then that line would have gone all the way to that value. So basically the outliers are not included in your box and whiskers. You're just marking them on your graph. Do you want to ask me any questions right now? Okay. So here, this next part, they've given us a 5-number summary for this set of test scores. And they're telling us that the data set, so the number of values in this graph is 38. So there's 38 pieces of data, and with the 38 pieces of data, this is the 5-number summary. Is that okay? So it asks us, do any outliers exist? So how do we figure out if outliers exist? What do we do first? Very good. Q3 minus Q1, which is 82 minus 68, which equals 14. Good. Okay, what do we do with that value now? Good. We're going to multiply it by what value? 1.5. Very good. So in our calculators, we can go 14 times 1.5, and we get 21 is correct. Okay, so in order to find our lower boundary, we take our Q1 value and we subtract this. So 68 minus 21, and what does that equal? 47. Okay, and then we take our upper boundary, and what value do we take? We take our Q3, which is 82, and then what do we do to that? Very good. We add that same value. We add 21, and so our upper boundary is what? 103. Good. Okay, so based on our lower boundary value and our upper boundary value, are there any values that are smaller than 47? Yes. So are there any outliers in this data set? Yes. So we are going to say yes, 41 is an outlier because it is less than 47. And there could be more outliers. We're not exactly sure because we don't have our data set, but since the low value is 41, any values between 41 and 47 could be outliers. Okay? B says, does the value 75 need to be an actual data value in the original set of test scores? So remember how on this one, my median is 16? It is an actual piece of data and it's the median. Does that make sense? When is the median not a piece of the data? When you have to take the average, exactly, when you have two middle numbers. So if they are telling us that the data set is 38, what would we do to figure out if this median of 75 is an actual piece of data? So you know on here, what did we do to find this median? We took our data set, which was 15. We divided by 2, which made 7.5, which rounded to the 8th number was my median, which was included in the data set. If this had been 14, we would have gone 14 divided by 2, which is 7, and my 7th and 8th term, I'd have to take the average of them. So if it's like a whole number, then it's going to be the average of 2, and it's not going to actually be in your data. Where if you get your 0.5, you ran it to the next number, and it's an actual piece of data. So what would we do on this one in order to figure out if this value is actually part of the data set? What would we do? Very good. We're going to take 38 and divide that by 2, which equals what? $19. So what does that tell us? Right, do you guys agree? No, it's not going to be part of the data set? Okay, because we would end up taking the 19th and the 20th number to get the median, right? So 19 and 20. So the answer is no, it does not have to be, or an actual number in the data set, because the value is the average of the 19th and 20th numbers. And the only reason why I said no, it does not have to be, is what if those two numbers were both 75? Does that make sense? But it still isn't going to be this number, it's going to be the average of the two. Okay. Do you guys want to ask me a question? Yeah.
How did you get 38?
Back here at the beginning, right here, it tells us that the class size was 38. Any other questions? We're good? Okay, so now we're going to talk about percentiles. Sorry, thought somebody was asking a question. Okay, so we're going to read here first. Percentiles are a way to measure the location of a data value in relation to the other data values. The value of the percentile ranges between 0 and 100, which would make sense because things are out of 100%. Okay, as an example, the 95th percentile means that 95% of the data values are less than or equal to X. X represents the location of the value related to the other data values in ascending order. So, how you find a percentile. In order to find a certain percentile, first you need to list your data in ascending order, which we've been doing for our 5-number summary and almost everything we've done so far this unit. Okay, all data values must be included in the ascending list. In addition, find how many items are in the list of data values. Okay, so when you're finding your percentile, how far to count represents the value you get from left to right, indicates how far to count in your ascending list of data values. There are two possible results. Okay, so N is your number of data values. So like in our last list back here, N would be what value for this up here? How many numbers are in my data list? 15. So looking at this, my N would be 15. And then you're going to take that value and multiply it by your percentile. So if they were wanting to know the 50th percentile, you would end up multiplying it by 0.5. You would take 15 times 0.5. Okay, and then whatever answer that gives you, that tells you how far you're going to count. And then to find the 50th percentile. Okay, so this is important, these two pieces. If you get a whole number, then you have to add 0.5 to it, and you take the average between those two values. If you get a decimal, then round up. Regardless of what the decimal value is, you will always round up, and then you'll take that exact term. Okay, so if it's like 5.2, you round up to 6. You always round up. If you don't have a decimal, if you get a whole value like 5, then you take the average of the 5th and the 6th number. Okay, that is how you do percentiles. So, looking at our first data set, it says, find the 37th and the 60th percentiles for the data shown below. Nice thing right here, they have written it in ascending order for us already, so we do not have to put this in order. Okay, The next thing we need to do is figure out how many pieces of data we have. And actually, if we look right here, they told us there's 20. But it's always a good idea to number them. So we're going to go ahead and number them just so we can see what's going on here. So I'm just going to write above here my numbers. Okay, so to find the 30th percentile or 37th percentile, they've already done the work for you. So we're figuring out our count value, how far we're going to count into this data set. 20 times 0.37 is 7.4. So we round up to the 8th number. So on here, if you go to the 8th number, the value for the 37th percentile is 32. Okay? So that means if you want to be within the 37th percentile, you need to score at least a 32. Okay? So anything 32 and below is within the 37th percentile. Okay? For the 60th percentile, same thing. My n value, the number of values in my data set is 20. We multiply that by 0.6 and we get the answer of 12. Okay? It says so add 0.5, which gives you 12.5. You could also think of when you get a whole number like 12, you're going to find it between 12 and 13. So you go to 12 and 13, and my values there are 56 and 78. And so we add those, divide by 2, and get the average. So 67 is the value that's going to get me to the 60th percentile. Does that make sense? Do we have any questions right now? Okay, so here is our next data set. It is not in order for us. First thing we have to do is write it in order. So I always start with my numbers that are less than 10. And if we go through here and find all the numbers less than 10, I have a 5 and I have a 2, it looks like. Did I miss anything? Okay, so writing this in order, we have 2 and then 5. Okay, next I get all like my 10 values that start with 1. So I'm going to go through this data list, circle all the numbers that start with a 1. And I have 11, 15, 17. Okay, next I'm going to get all the values that start with 2s. And so it looks like I only have 20 and 21. Okay, then all the values that start with a 3. And we have a 31 and a 34. All the values that start with a 4. And we have 45 and 48. All the values that start with the 5. So we have 50 and 56. All the values that start with the 6. Looks like it's just a 68. 7s, we just have a 76. 8s, we just have an 82. Wait. Very good. 82 and an 89. And then our 90s, we have 90, 91, 93. Okay, the next thing I'm going to do is number my data set here. And it looks like I have 20 pieces of data. I'm going to double check and count here to make sure it equals 20. And there are 20, so it looks like I did everything correctly. You always want to double check yourself here because if you leave out a number, everything's wrong. So if you don't get everything in order and you don't get all of your numbers, you're done. So make sure you get everything in ascending order. Every number's there. Okay, so next it asks us to find the 45th percentile and the 90th percentile. So starting with the 45th percentile. Okay, what do we multiply in order to find our count number? What number we count into our data? We take our n value, which in this case it is 20, and we multiply it by our percentile, which is 0.45. So in your calculator, 20 times 0.45 equals what? So if you had a calculator, you'd be multiplying those numbers right now, and you get the value of 9. What does that mean? Because it's a whole number, we're going to find the average between 9 and 10. So if we go to 9 and 10, my values there are what? Good. So we go 34 plus 45, and we divide by 2. And we get 79 divided by 2, which is 39.5. So that is the value at my 45th percentile. Okay, I'm going to give you a minute here to find the 90th percentile on your own. When you get the answer, raise your hand and I'm going to check it. Okay, so 90th percentile, what two numbers do you end up multiplying? 20 times 0.9 or 0.90. When you get that, what does that equal? Thank you, 18. So that means we're going to look at the 18 and the 19th number. 18 and 19th number are 90 and 91. So we go 90 plus 91 divided by 2. And you get 181 divided by 2, which is 90.5. Okay, 92nd percentile or 90th percentile. 92nd, I can't talk. 92nd percentile. Let's do one more. Yeah, sorry. Find the 92nd percentile. So we're going to do the same thing as we just were doing, right? We're going to take 20, our end value, times 0.92, and what do you get? Good, 18.4. Since I got a decimal, I'm going to round that up to what? 19. So in this case, the value will be what? 91. Okay? Any questions?